All right, second section of chapter one. The problems that we're going to be looking at are going to be a little bit different than quadratics or linears. They kind of fall into goofy categories. I'm mostly going to be talking about radicals in this video. You should check out the PDF notes for this idea called U substitution, which is another sneaky way of solving other types of equations. What we're going to look at is radicals right now. And in a radical equation, we need to square both sides once the radical is by itself. So right now we have this square root that's all by itself. So we can square both sides in order to get our answer. If I can get a color, there we go. No. All right, so we square both of these, and that gets rid of the square root because squares and square roots undo each other. And all we're left with is an x minus 3 over here, and then 4. And then it's easy peasy. X equals 7. Easy peasy, as I just like, what is it? Now, one thing that we have to be careful about with these radical equations is we need to check for extraneous solutions. We need to make sure that this thing actually works. It is possible in these problems to get an answer that doesn't actually work for our problem. So we need to do a check step and ensure that the number that we got actually works. So we got square root of 7 minus 3. We want to see if that equals 2. Does the square root of 4 equal 2? Yeah, it totally does. Okay, cool. We're all set. Do that one more time. Yeah, sure. So square both sides. That gets rid of the radical, and that's literally all it does. Everything that's inside of the radical stays exactly as it is. All it does is square the radical and get rid of it because we isolated it. Well, it didn't really isolate it. It was already by itself. Do a little solving. 3p equals 21. Am I getting 7 again? Oh my gosh. How are these both 7? That's madness. Whatever. So then we want to take that answer and we want to put it back in to this p. So we got the square root of 3 times 7 plus 4. We want to see if that equals 5. So we end up with the square root of 21 plus 4. That equals the square root of 25, which does equal 5. Note that there's no plus or minuses in that check step. The reason there's no plus or minuses in that check step is because we are square rooting to evaluate or simplify. I'm not doing square root as a solving step. If you ever square root as a solving step, you need to include a plus or a minus. But we're not doing that today, so I didn't include it. Loading. If you want to see another example, here's one from the PDF notes. Now, one thing to be careful of is you need to try to get this square root by itself first. If we just square right away, we're not allowed to. So I need you to note that this is not the same as 3 squared plus x plus 2. That will not work. That is not true. Put a big note in your notes that that is not true. That is what you need to foil. Right, Maleficent? Yeah, she even agrees. She's here and mad because you all are trying to just distribute squareds over additions. You can't do that. No fair. Right, Maleficent? Isn't that right? Isn't that right? Get out of here now. Get that radical alone first. Now, there's times where we can't do that. So in this one, we've got more than one radical. Since we've got more than one radical, we need to isolate one of them. We're going to square that one away. Then we'll isolate the other one, square that one away. So we're going to have 2 squaring steps in this problem. I'm going to get rid of the 7x plus 2. I'm sorry. I'm going to get rid of this. I'm going to isolate this one first. This is what I'm trying to say. My goodness. I can do either one first. It doesn't matter which one we get rid of first. We just have to pick one. And it really doesn't make a huge difference which one we do. So I'm going to square away that first square root. So it's going to get rid of the square root on my x plus 2, which is great. Oh, huzzah. However, it does not get rid of the square root on the 7x plus 2. That needs to be FOILed. That is a binomial being squared. And if you have a binomial being squared, you've got to FOIL it. So I'm going to use my binomial square trick. So I'm going to do 6 times 6, that's 36. And then on the end, I am going to get my nice 7x plus 2. So that's nice. However, in the middle, I'm going to have a 2 times the 6, so that's 12, and the square root of 7x plus 2. So I ended up with a huge mess on that right-hand side. However, I did reduce the total number of square roots I've got in this problem now. I started with 2, now I only have 1. So I can try to get that square root of 7x plus 2 by itself now. So I'm going to do a little cleanup here on, let's see, well, let's just start bringing stuff over. Let's actually do that. I'm going to subtract a 2 from both sides and subtract a 36. And we'll bring that 7x over, so minus 7x. So we end up with negative 6x minus 36 equals, and we're still left with our negative 12 square roots of 7x plus 2. I'm going to get rid of that 12. We could keep the 12, but here's what I'm thinking. If I divide both sides by 12, I'm going to end up with a fraction on the other side, and I don't really want to do that. So my sneaky trick that I'm going to do is I'm just going to divide by negative 6. That's the biggest thing I can divide 12. I can basically divide everybody by. I can divide the 12, the 36, and the 6. I can divide them all by negative 6 just to clean up my problem. If I wanted to, I could square right now in that brown step, but I'm trying to clean it up a little bit, because it's brown. All right, and then I end up with 2 square roots of 7x plus 2. And hopefully now you can see too, like if I had divided by 12, I wouldn't have been able to divide that negative 6x minus 36. But I can if I do negative 6. And it's just going to make my foiling just a little bit easier, because I am going to have to foil again. Now I can square both sides, because I've just about isolated the variable. Isolated the radical. I haven't perfectly isolated it, but I've gotten rid of most of it. All right. Now over on the right-hand side, I can sort of do that distribution because it's a one-term thing. It's like a 2x. You can make that a 4x squared. This is a 2, but my x is really gross. It's 7x plus 2. On the other side, that needs to be FOILed. So I get x squared plus 12x plus 36. Let's distribute this 4 into there. So we get 28x plus 8. Let's keep this x squared plus 12x plus 36. And now I have a quadratic equation. Quadratics need to be set equal to 0. So that's my next goal. Get this thing equal to 0. We got to subtract a 28x and we got to subtract an 8. So we get x squared minus 16x plus, that was a 36 minus 8, so that's 28 equals 0. All right, now I need something that multiplies to be 28 and adds to be 16. 2 and 14 will work great. So we get x equals 2 and we get x equals 14. Woohoo! Are we done? No. You might have, it's been so long, but you got to remember there is a check step. We need to check to make sure that these two solutions work in our problem. So I'm going to grab that equation from up top. Like you have to rewrite it, but I can. Come on, come on. I can do little cheats. Little cheat. Bring that down to where I'm working. Okay, so let's put in 2 and make sure that works. So when we put in a 2, we get the square root. Can I have a pen, please? Square root of 2 plus 2 plus the square root of 7 times 2 plus 2. We got to see if that equals 6. So we get the square root of 4 plus the square root of 7 times 2 is 14 plus 2 is 16 equals 6. So that's 2 plus 4. Yeah, that equals 6. Sweet. So this 2 works. Awesome. What about the 14? We get the square root of, let's see, 14 plus 2 plus the square root of 7 times 14 plus 2. We want to see if that equals 6. So get the square root of 16 again. Okay. Plus the square root of, what's 17 times 4? 98 plus 2 is 100. And I get 4 plus 10 equals 6? Nope. So 14 is extraneous. 14 is an extraneous solution. It does not work in our problem. It works in terms of the algebra, but if we go back to the original problem, it does not make sense. That's what I was talking about earlier about that plus or minus. There's certain times where it makes sense and certain times it doesn't. It's kind of creeping up in an odd sense in this one. So 14 is extraneous. Our only answer is 2. So quick summary of doing these problems. First thing, isolate each given radical. Get rid of the radical using exponents, so squaring. Solve the resulting linear or quadratic, and I cannot stress enough, check for extraneous solutions on these problems. What I would like you to do at this point is go to the PDF notes and browse the U substitution problems and get an idea of how to do them. We're going to be probably doing a lot of those in class, but make sure you get a preview of them before you come to class and do your check for understanding. All right, bye-bye.